So let us look at another example. For example number 2, everything is similar to the example number 1, right? You have a 6-blade turbine. The DT is 1.83, the DA is 0.61, the E is 0.61, the W is 127 mm, the H is 1.83, but here you have a rubber latex compound with a viscosity of 1200 P, right? And a density of 1120. The turbine, the value of N is still 90. What will be the power required to operate this mixture, right? So it is quite similar to our example number 1. The only difference is that our value of mu here is 1200 P. Okay, so you must be able to change this into kg meter per second. So what is 1000 P in kg meter per second? So once you know this, everything else will be very easy, right? So dA is 0.61, N is 90, you change it to per second, so you get 1.5. Rho is 1120 divided with 120. So meaning to say here is that 1200 P is actually equal to 120 kg per meter second. Okay, so you must be able to know this conversion. If let's say you are still confused, you can always search the internet to find this conversion factor, right? So that once we substitute all the values we put in our calculator, we'll get a value of 5.2. Okay, 5.2, your Reynolds number. So Reynolds number is RE is less than 300, right? So it did not mention anything about baffle here. So if it's not mentioned here, we can just assume that this tank is not baffled, because it's not baffled mention anything about baffled here, right? So we can just say that the tank is unbaffled, but the value of Reynolds number is less than 300. So since it is less than 300, right, for very low Reynolds number, power requirement is independent whether the tank is baffled or not baffled, right? So the formation of vortex does not occur. So we can just ignore the value of Frob number. Okay, so if we ignore the value of Frob number, so we can just find the value of our value of N P, our power number, and we'll get a value around an estimation of 12.5. And we substitute the value of Np, the value of our rotational speed, impeller diameter density, and again the value of Gc is equal to 1. So we get a value of 3990 watt. So that is the power requirement for this